Hello and welcome on my YouTube channel. So this session today is about basic math for finance, and we want to see how you can deal with X factor and changes in percent. Why I'm talking about it? Because I see often wrong calculations, but I'm honest, I'm also here not an exception. Sometimes I'm also doing wrong calculations. And the other thing is some people don't know how to calculate, and hopefully we can change this today. Yeah, change, percent and X factor. So first of all, X percent just means X 100ths. So X divided by 100. And X per mil just means X thousandths. So X divided by 1000. And now we have to define two time points, T1 and T2. And T1 shall be an earlier time point than T2. So then we can say what is the X factor? And the X value is then the value of T2 divided by the value of T1. So the value at the end divided by the value of the beginning. And why I'm calling this X factor? Yeah, usually people are saying, for example, that an annual growth is 3x. And this means that the value today is 3 times higher than it was 1 year ago. And yeah, the 3 is then the factor which is written for the x. Now, the x is usually used as the multiplication character here also, and the 3 would be then the factor for the x, so the X factor. That's the reason why I'm calling this X factor. Yeah, and the percent change, the change in percent, is then the value at the end minus the value at the beginning. And this then related to the value at the beginning multiplied with 100, because we want to have the change in percent, therefore times 100. Yeah, and this can be expressed also differently with the X factor. So the percent change is X factor minus 1 times 100. Or we can also see this equation from the other direction. And then you can say the X factor is equal to 1 plus percent change divided by 100. And last but not least, the absolute change. What we have here is, of course, the value at the end minus the value at the beginning. But let's do some examples here. The first example is where we have a drop from an all-time high by 75%. And then the question is, which change in percent is needed to get back again to this all-time high? It's of course not 75%. Maybe stop at this point the video, do your own calculation, and then we will see whether we are coming to the same result. Let's start into the calculation here. First of all, we have the X factor, which is related to the drop. So the drop means a reduction of the value here, minus 75%, so minus 75 hundredths. And then the X factor is 1 minus 75 hundredths, so 0.25. And the X factor of getting back is then the reverse thing. So that's then 1 over the X factor of the drop. And this is 1 over 0.25, which is 4. Yes, and the percent change, the change in percent, this is then the X factor minus 1 times 100. So 4 minus 1 times 100, and this is 300. So the change which is needed afterwards in percent to get back to this all-time high is plus 300%. but we can also see this if we assume the all-time high with $100. Yeah? So we have a drop of 75%. So this means a drop by $75 from $100 to $25. And then we want to get back. So from 25 again to $100, and it's clear the factor 4 is needed. And this is nothing else as if I put on top of the 25 additional 3 times $25, and $25 is 100%, so 3 times 100, this leads then to 300%, which is needed. Example number 2. If price increase over 10 years is 25%, what's the X factor for the money value? And I'm calling this here MV. And what's the money value loss in percent? Yeah, let's take a look. So the X factor of the price is 1 plus 25 hundredths, so 1.25. I think that's clear. And this can be expressed also as 5 over 4. But the X factor of the money value, this is the reverse. So 1 over the X factor of the price. And this is 4 over 5, meaning 0.8. Yeah, and then we can calculate the percent change. And this is then the delta to the 1. So 0.8 minus 1 times 100. And this is minus 20. So the change for the money value is minus 20%. And this means that the money value loss will be 20%. But let's take an example where you have a product price of 100 euro at the start. So plus 25% means after 10 years, you will have a price of 125 euro. So this can be easily calculated. And then you have to think about the 125 euro. At the beginning, I'm getting for this money 1.25 products. But at the end, I'm getting only 1 product. And for this money value factor, I have to take the number of products at the end divided by the number of products at the beginning. And this is 1 over 1.25, which is 0.8. Yeah, and the 0.8 is a delta of minus 0.2 to 1. And this is minus 20 divided by 100, so minus 20% for this change in money value. Example number 3. If the sales tax is 19%, and if this sales tax will be reduced from 19% to 16%, then what's the sales price reduction in percent? It's not 3%. It's a different value. So we have a tax factor change, which is from 1.19 to 1.16, right? And the price X factor is then this factor at the end divided by the factor of the beginning, and this is 1.16 divided by 1.19, and this leads to 0.975. And the price reduction is then the difference to 1, so 1 minus the 0.975. This is 0.025, and in percent, this is 0.5%. So it's not 3%, it's 2.5%. What about multiple equal X factors? X factor of n periods, and I'm calling this X factor n, is the multiplication of X factor n times. And this is nothing else as if you put the X factor to the power of n, to the power of number of periods here. Yes, and if I have the x factor n and the number of periods n, and I want to have the x factor, then you see this equation. I have to take the x factor n and then to the power of 1 over n. The last equation, if I have x factor n and the x factor, and I want to have the number of periods, I have to take the log function. So the log of x factor n divided by log of the x factor. But here it doesn't matter. You can take the natural log function or the log to the base 2 or the log to the base 10. This doesn't matter, but it has to be the log function. Let's do also here examples. Example 1. If your annual gain is 60%, what's the average monthly gain? So the number of periods is 12 here, because 12 months are building 1 year, right? And we also have the x factor n. So it's 1 plus 60%. So 1 plus 60 hundredths is equal to 1.6. And then we can calculate. So the x factor for 1 month is then 1.6 to the power of 1 over 12, which is 1.0399. And the monthly gain is then the delta to the 1, so it's approximately then 4%. And example number 2. If an annual inflation is 3%, then after how many years 50% of the purchasing power is lost? What do we have here? We have the x factor of the annual inflation. This is 1 plus 3 hundredths, so 1.03. But what we need here is the annual x factor for the purchasing power, and this is the reverse thing. Now we saw this already before. So this is then the factor 1 over 1.03. Then we have the x factor n of the purchasing power. This shall be 50% less, so meaning we have this x factor n equal to 0.5. And then we can calculate. We have to take the log of x factor n divided by log of the x factor. And you see, then we are getting the value of 23.45 years. So after 23.5 years, you are losing 50% of your purchasing power if the annual inflation is 3%. Yeah, what can be taken at the end here? A few tips. The first one is calculate always the x factor before you are calculating other stuff. I would always calculate the x factors here. And take simple examples where, for example, the absolute value is 100. We did it in some examples, for example, with the all-time high here, which has been assumed to be $100 or 100 euro. And calculate all absolute values before increase, before decrease, after increase. For all things which are happening, calculate the absolute values such that you have a good overview here. Okay, that's it for today. I hope I didn't confuse too much. Happy calculation, and I hope that we will see us again in one of the next videos. Thank you and bye-bye.